I'm in the process of restoring and repairing this Addo mechanical calculator, and in the previous videos I've cleaned up the unit, made some adjustments, fixed a few things, and it's now starting to work. It was all kind of bound up, the usual thing for mechanical calculators, and the biggest part of the job was cleaning it. I've been asked to show the cleaning process, but I don't generally do that. That's not really what the video is about. And also taking a camera into the area where I clean these would probably destroy the camera, so I can't do that. But the video is not about that anyway. It's about the repair and how you go about cleaning these. It's entirely up to you. And also I would a word of caution: if you do take these apart, they're not necessarily assembled the way you might expect them to be. And for example, taking this top plate off, I took this top plate off in order to clean underneath it and to clean the tape transport mechanism. There's a kind of reverser system on this. There's little tabs on the end of each end of the tape that are used to reverse the direction of the advance of the ribbon. And that was jammed up, so I took the plate off to clean it and also get access underneath to clean it. But you need to be really careful when you do that. So you might expect all these to be riding on a common shaft, but of course they're not, because they raise and lower independently. So when you take this guide plate off, if you're not very careful, these can all fall out and you cannot get access to the bottom of them without dismantling the entire machine. So if you do start taking these apart, be really careful. I don't really want to show that because it might lead people into making the assumption that you can just take these apart and just put them back together without any issues, but they can be a real pain to reassemble if you're not familiar with the way that the mechanism works. And if you do take one apart and you haven't done it before, I recommend taking lots of close-up photographs, making notes, because the information on reassembling these is fairly hard to come by. Okay, so that said, the bulk of the repair was cleaning. It is now looking like it's starting to work, but the next step is to get it printing, because if it's not printing, then you can't really see how well it's working. And in response to the previous video where I mentioned the tape was dried out, someone suggested in one of the comments that we could soak it in isopropyl alcohol or something similar. Now that might work to a certain degree for a limited time on a newer tape or newer ribbon, but ultimately I've tried it a few times and found that on a newer ribbon that's just dried out and is not printing very well, it might appear to give good results. You'll get you'll do it and then it'll start printing quite well. But you'll come back a week later and it will actually have made the tape far worse. It will actually accelerate the drying out process. In fact, isopropyl alcohol is used to dry out this sort of thing, so it's not a good idea to do that. Also, on a tape like this tape's probably 70 or 80 years old, and just to prove the point, I have soaked this tape in isopropyl alcohol, and we'll see what difference it makes. And so I soaked in alcohol, allowed it to dry, put it back in, and we'll now try to print with it. And as you can see, it's doing nothing at all. I'll zoom you in so you can see the paper a bit better. So previously I was getting some marks on the paper. The process does make the tape look quite nice and clean, but we just tried printing again. While it was making some fairly faint marks before, now that I've gone through the process, it's not leaving any marks whatsoever. The paper's binding up, by the way, because this is not proper rolled paper, it's just sheets that I've sliced. I've got some proper paper on order, but until that turns up I'm having to use this. But the IPA process has now completely dried out the tape and it's not leaving any marks whatsoever. So if you don't have a replacement tape and it's printing fairly faintly, I would not recommend putting it in isopropyl alcohol. You'll either wash out the remaining ink or you'll cause the ink that is there to completely dry out. The ink's not supposed to be dry, and isopropyl alcohol is very good at drying things out, so just be aware of that. So the next thing is to replace the tape, and I don't have, this is an 8mm wide tape, or approximately 8mm wide, as opposed to the normal 1/2 inch tape. So what I'm going to do just to test this is slice a tape. I've got an 8mm tape on order, but it could take quite a while to get here. So just to see if the machine's capable of printing, I'm just going to fit a piece of newer tape that I've cut down to 8mm, and we'll see if we get any impressions being left on the paper. I've cut down a wider tape so it fits into this machine. It's just the short length of it. If this does work, I'll do a longer length and put it on the reels. I just want to see if the machine's actually capable of printing, so we'll try entering a number, press print, and as you can see, or hopefully you can see, it's now starting to print some characters. They're still kind of dark at the bottom and very faint at the top, so most likely the roller is not in the right place. You can adjust the position of the roller, and I think I need to lower it slightly, but as I said, what I'm trying to do here is just make sure that the machine is capable of printing. I have run it through very slowly and made sure that it's putting sufficient pressure onto the paper, and it is. Also, it's running quite slowly. It's only running at half its normal voltage, and that will also impact the printing. It won't be hitting the paper as hard as it would normally, but even so, there should still be enough pressure for it to print. So we'll try printing again. And it is actually printing. As unfortunately it's very faint, I don't know if you can see it at all, but it is printing, and it is printing the correct characters. So try it one more time. Okay, good. So it is now printing all the way across, so it will be worth me making up a full length tape. It is printing the full height. The one is printing, and it looks like it might just be a case of it's not running fast enough, so I'll increase the voltage a bit further, make up a longer tape. Obviously if we keep printing in the same part of the tape, it's going to be very faint anyway. Let's pull the tape through and we'll try a different part of the tape. Okay, so it is getting better each time I try it, so I've got a feeling that as it frees up and the mechanism's going a bit faster, that that's going to help improve the printing quality. So I'll get this set on a higher voltage, I'll get a longer length of tape prepared, and we'll try this again. I've got a fresh piece of tape in here, and I've got the voltage now wound up to about 180 volts. That should easily be enough for it to print reasonably well. However, if I put in say all 8s and try and print, it's actually printing quite clearly, but only in one part of the character, but it's consistent all the way across. Now I've wound this through very slowly, and the part that's printing clearly is the bit of the character that is kind of on the peak, if you like, of the roll, the bit that's closest to the hammers. And I think what's wrong with this is I've got a feeling that the rubber roller, let's take the paper out, is just so hard. I mean, it feels like a piece of rock. I think it's just so hard that the character can't be properly formed, because obviously it's this is flat, and I think what's wrong with it is the rubber roller is not allowing any deformations, so it's not able to print the entire character. The bits that are kind of moving away around the curve from the paper are just too far away from the hammer to be creating any transfer of ink. So unfortunately I need to replace the rubber roller. It's not difficult in itself, but it does mean taking this part of the mechanism apart. At least then I'll be able to straighten out the shaft. So I'll get this taken out, I'll get the roller replaced, but as I said, it is like a piece of rock. It is very hard, and obviously that's going to stop the printing from being successful. Effectively it's a curve and the hammer's flat, so it's only going to print on the the part of the roller that's closest to the hammer. So I'll get this out, we'll get it replaced, and then we'll see if that improves the printing. I've taken out the rubber roller. I've also taken out the lower roller. This is the roller that sits underneath the rubber roller, and the paper sits between the rubber roller and this. You can see it's all rusted up. So I'll take this out and clean it as I've got the rubber roller out. This is a good opportunity to clean this as well. Also, I need to make up another one of these. This is the side support for the paper reel, and one's missing. That's the screw that we found is supposed to hold this in place. Fairly easy to get out. It's just really a case of taking the guides out and then removing the screws that hold the two pivot plates in. It's a bit of a pain getting this out past. There's some little sprung fingers on the plate, the guide plate, and you just need to be careful when you put the roller back in. That's what leaves these lines. I'll show that when we refit this. But at the moment, the next step is to replace the rubber roller. I need to replace this. You can see this is loose. It's actually not supposed to move about like this. Someone's replaced it at some point with just a piece of wire of some sort, but I'll need to replace that. But this is the problem. It's supposed to be rubber. If you can hear this, I'll put it next to the microphone. But it is rock hard. And I think what's happening is the hammer is coming up trying to print, but because it can only really press hard on the peak, if you like, of the curve, it's only really printing part of the character. So I'm going to replace this. I've shown how to replace rubber rollers before. I'm just going to remove this rubber, put a fresh piece on. If I can't find one of the exact correct outside diameter, I will of course machine it down to the required size. So I'll measure this first. I'll probably add about 0.5 millimeter to the diameter. This has no doubt shrunk slightly over the years. I don't have a specification for it, but that will also help. And this is sprung against this, so it's not going to cause any issues there. It will just move the paper slightly closer to the hammers, and because it will be softer, that shouldn't increase the force that the hammers are seeing, so it shouldn't do any damage. So I'll get this over to the workshop. I won't video this, it's take an hour or so, and I will also take the opportunity to straighten this bent shaft out. We'll get back onto the roller in a few minutes. Before that, I thought I'd just take this cover back off and show you the inner workings of the machine. I've been asked a few questions about this, and just thought I'd address those here. And one of the things I had done earlier, I had already taken off this plate, but I purposefully left part of it unfinished, so I haven't lubricated this, simply so I could show the sorts of things that we're finding and need to be addressed. So the first of these is the tape advance. Incidentally, I call the ribbons tapes, and it annoys some people. It's just a habit. But when I say tape, just replace that with ribbon if you prefer. Now, the way this works is that each end of the ribbon, there's a small, there's kind of an eyelet that's been riveted into the tape. And as the tape comes to the end, it pulls the levers up, and it does that depending on which direction the ribbon's travelling. And the way that the ribbon is advanced is there's this lever over here on the machine, and that moves across once per cycle, once per print cycle, and that engages with this pin, and that causes this slide to move across. And what you can see, hopefully, is there are a couple of ratchet wheels and some pulls, and as we move this across, you'll see in this case the one on the left is rotating one tooth per cycle. When we get to the end of the ribbon, then one of these two actuators will be pulled up, and I'll just hold the slide still. So when it gets pulled up, it reverses this pull plate, this kind of T-shaped plate in the middle, And when we now move the slide across, you can see the one on the right is moving. So it was the one on the left, it's now the one on the right. And it seems to be working. However, these are really tight, so when I try and move these, it takes a lot of force. Now if this was in the machine, that's enough force to actually snap the tape or jam the machine up, because obviously it's trying to move this across, and if it can't move because the tape's kind of jammed, then it's going to transmit that force somewhere, and either the tape will break or something else will. And the reason this is not working is because the basically this transfer lever, this T-shaped lever, is sticking. There's a slide underneath here that it runs on. You probably can't see it, but it's a slide and spring. That should move very freely. This should rock back and forth with almost no force at all. And you can see it's pretty much bound up to the cross slide. So that's the sort of thing you find on machines like this. It's usually a combination of lots of little things that cause it to stick or to jam, and it's finding them and freeing them up. It's not always as obvious as it might seem. And one of the comments I had was, when I'm doing machines like this, do I look at it in terms of the function of the particular part? The answer to that is mostly no. Sometimes I will, and on machines like the Friden that we looked at a while ago, I will kind of put it into certain modes, so multiplication or division or addition, and then cycle it through that way. This is just an adding machine, so I don't need to do that, but the problem is that the parts that are binding it up are not necessarily the parts that are supposed to be in operation at the time, and so you can't necessarily look at it in terms of the part of the cycle that's supposed to be operating, because the part that's binding up might be unrelated to that part of the cycle. So it's just really going through and seeing which bits are bound up, seeing what's not working, and then trying to figure out why. So in this case, we can see this isn't working properly. It is actually working. It's just, again, one of the things to bear in mind is how much force is required to operate a certain part. And it, again, not always obvious as to when a part's bound up. It might just be there's a strong spring, or it could be sticking. So I'll get this cleaned and see if we can get this freed up. As I said, this little slide, this little plate should move across freely, but as you can hopefully see, it's very hard to move, and that's what's causing this to not operate correctly. So I'll get this cleaned up, lubricated, and we'll see if we can improve its operation. So that's the ribbon advance mechanism sorted out. I cleaned off all the congealed grease, freed it all up, checked all the parts where they should be and weren't bent, lubricated it, and now this moves quite nice and freely. So once we've got this refitted onto the machine, we can properly test the tape. You can't really test it fully without this being fitted to the machine, because this slide actually runs on the back edge of these two forks. But it's now moving freely, nothing's bound up, so it should work fine. So that's ready for refitting. I've cleaned up the idler roller. This is the one that sits underneath the rubber roller, so that's ready to go back in. And I've also made up another side cheek for the paper reel. I've made this as a mirror image of the other one, because obviously they sit at opposite ends of the reel. So they're ready to refit. I was asked about the model number. I said some models were different to the decimal models, and how can you tell them apart. Models 9 and 10 were the UK currency models, and if we look on the plate up here, hopefully you can see. Let's move the camera so you can see it a bit more clearly. Hopefully you can see on here we've got the model number, and it says 9E. So this is the model 9. The E is for electric. There was a mechanical version that had a big lever on the side, but this has got the motor, so it's the 9E. Okay, I'll move the camera back. So the reason I removed this plate, you don't need to remove it to get the roller out, was to give you a better look at what's inside the machine. And they are quite fascinating to look at, and in fact if you look at these carefully and think about it, a lot of what's in here is familiar if you've worked on other types of machines. And one of the questions I had on this was, how do you identify which parts do what? And in all honesty, most of these machines operate in very similar manners. The only thing that's different is how the particular functions are implemented. And one in particular, one feature you see on hundreds of different machines is this kind of interference hammer action system. And what I mean by that is you have an anvil or something that's moving, and whether it operates on something else is determined by putting something between them. And that's something that goes right back thousands of years to old water mills used for forging materials, through jacquard looms and through machines like this, into the pin control mechanisms of paper tape punches, and you see it a great deal. And a question I had on this, because I mentioned that I'd cycled this through and checked the force was correct, was how do you adjust the force that the hammers are applying when you are printing? And I'm probably misspoken, didn't really explain it very well. I was checking that the force was being applied. You don't really adjust it directly. In this particular machine, in some machines you do, but in this particular machine, this block here has got some plungers, these, and some springs. And the way this operates is when it wants to impact the hammers onto the paper, this entire block rocks towards the paper, and it pushes the hammers towards the paper. So it will push the hammer this way, and it does that by moving this block. That moves this pin. The force goes through this spacer and onto the hammer itself, and then pushes it against the paper. The force is actually controlled by springs inside this metal housing, and we can see that. I'll move the camera a bit closer and hopefully you'll get some idea as to how this works and what's inside. So as I mentioned before, once you take this plate off, be really careful with these machines. All the hammers are independent and they are not held in by much once that plate is out, and if they drop out they are a real pain to get back in, so just be careful. They come off starting at the right hand end one, so just make sure this can't move across. If you're going to work extensively on it, what I recommend is that you put a small wedge down this gap to stop the hammer falling out. Okay, so the force is controlled by these plungers. And if I put a screwdriver in this gap and then move the hammer across, you'll see that the plunger is sprung. So this, hopefully you can see that plunger, it doesn't go very far, but it's moving in, and you can possibly also see down here the other end of the plunger coming out. So it's a plunger, spring and a pin, it's all one piece. And that, as it pushes across, once it reaches the paper roller, it starts to compress the spring. So it's the spring that determines the force, along with the inertia of the hammer, depending on how fast the machine is running, but the static force is controlled through the spring. So one of the things you need to do when you're working on these is, I've seen quite a few machines that have this type of mechanism where these slides have completely bound up, they've locked up, and then the first one that won't move moves across, tries to push the hammer across, and then the machine can't turn any further because the pin's stuck and it won't slide out of the way. So just bear that in mind. Another question I had, which was very interesting, was how it blanks certain digits. Was there a blank position on the hammer? And the answer is no, there isn't. Probably going to be hard to see, but in the hammers there's a cutout, and this is what I was talking about with this interference mechanism like you find on a pin punch for a paper tape punch. These intermediate levers raise and lower depending on whether you need to have a particular digit printed. If you don't want it printed, then this will go down a little bit and it will go into the recess. I'll just lower the light a bit and hopefully you can see that a bit more clearly. Each of the hammers has a recess in it. It's just at the end of the tweezers there, and if you don't want the digit to print, then this particular part of the mechanism moves down, and it then causes this part to be pushed into that recess when it moves across. So when this goes across under the pressure from the sprung lever, it goes into the recess in the hammer, and then the hammer doesn't move. If you want that particular digit to print, then this will engage on another part of the hammer that doesn't have a recess. It depends on how high the hammer is, of course, but it's then not lined up with the cutout, and that causes the hammer to be pressed across. So it's a very clever mechanism, something you see a lot in different machines, and once you become familiar with what they actually do, it looks very complicated the first few times you see these, but once you realise this is just a common thing that you've seen before in different forms, it becomes much easier to figure out how to work on these. So just look for the kind of common operations and mechanisms. They'll look very different in different machines, but once you figure out what they're meant to do, it all becomes much more straightforward. Okay, so the next thing we'll do is get back onto the roller. I might as well fit the roller with this plate off, just makes it a bit easier. If you do need to fit the roller with this plate in place, these are the little fingers I mentioned that make it tricky to get in. But all you need to do is, this will normally be sitting down here of course, all you need to do is put a piece of paper in here, and then you can slide the roller between this plate and these fingers, and the paper will kind of stop the fingers digging into the roller, and it will allow the roller to slip into place without damaging these. I did find that some of these were bent, so I've straightened them all out, so they're all in the right location now. So onto the roller and see if we can get the roller made up and whether it will fit. I've renewed the rubber on the roller, so I took off the old rubber. It was rock hard, came off a bit like plastic, and I fitted replacement rubber. This is nitrile based rubber, but what you use is up to you. This is probably one occasion where maybe you don't want to use silicone rubber, it might be a bit too soft, but this has got a bit of give in it. It's not rock hard like the original, but it's still hard enough to hopefully give a good impression on the paper. The next thing I need to do with this is to refit this ratchet wheel. This is the one that controls the advance of the paper, and when I took this off, it just had this it's like a piece of wire that somebody pushed through there, and it had a lot of kind of backlash, and so it wasn't really driving the paper very reliably. Now, I've looked at this fairly carefully, and I think it originally had a taper pin in it, so I've got plenty of taper pins, all different sizes. So what I'm going to do is just clean the hole up with a tapered reamer. So these are tapered reamers. Quite often you use them in clockmaking, that sort of thing. It's got a very shallow taper on it, but all you do is you pass them through the hole, turn them around. They've got cutting edges on them, and it's a cutting reamer of course, and just clean up the hole, find a pin of the correct taper and diameter, push that through, trim off the excess, and then this should be ready to refit. So I've cleaned up the two holes, make sure that they're clean and have the correct taper. It was really just full of dirt, I didn't really need to cut any material off. So all I need to do now is withdraw the reamer, and then I can put in a taper pin of the correct size. Looks like that one. Just gently tap this in so it won't fall out, trim off the excess, and then this will be nicely secured to the shaft, and we can start reassembly. So I fitted the taper pin, gently tapped it in, trimmed it to length, and now the ratchet wheel is well and truly secured to the shaft. So this is ready to start assembly. The other things I've done so far, I'll straighten these plates out, at least one of them, The two of these, one was bent, one was curved, and I figured it was more likely the curved one had been bent rather than the flat one had been flattened. So I've straightened that out, and I found a suitable nut so I can refit the screw that we found floating about inside the machine. So the first step is to refit the pinch roller, and that just sits in between these two pivoting arms. There's one of these at each side. There should be a spring on each end. This is what that odd spring was attached to, so I still need to find a spring of the correct size. This just fits into the hole at each end, and then it just floats up and down and is pressed against the rubber roller by the two springs. So I'll get this fitted. The next job is to fit the roller itself. I did have to take the ratchet wheel back off so I could fit this side lever, and there's one of these at each side. These just fit down the outside of this housing, and the pivot hole in the centre goes onto these pins. I've left the springs off the pinch roller for now. It'll just make it easier to get the rubber roller in place. We can put those on afterwards, and that will pull the pinch roller up onto the rubber roller. That's the roller fitted, the two side cheeks and the paper reel support, including the one that I made as a replacement. So check the roller will rotate nice and freely, and the ratchet still works. Not too much side to side play. So good, that looks fine. The final size I've made this at the moment is slightly bigger than it was. It was 20.8 millimeters. It's now 21.2. I can make it smaller if I want to, of course. I'm not sure if I've mentioned before that when you machine this type of rubber, it turns a kind of grey and has a kind of powdery texture on the surface. You might not care about that. It does have a tendency to also shed kind of grey rubber dust for a while after you've machined it. What I do to turn it back to this colour and give it a nice even matte finish is, while it's still in the lathe, spin it up and just gently hold a piece of coarse paper towel against the surface as it's spinning. You need to be careful, of course, it's rubber, it will tend to grab things like paper. So just a small piece of paper, a little wad of it, hold it against it, and it will tend to melt and reform the surface of the rubber, and it will turn it back to this kind of dark grey or black colour. Don't overdo it, it will of course end up misshapen if you get it too hot, but it will very quickly heat up, being rubber, and it turns this nice matte finish and gives it a nice texture, and also stops it shedding dust. So I do that with the rollers if I have to machine them, as I have with this one. Okay, the next thing is I want to refit this top cover. So that's this part, just to make sure that I don't accidentally knock out the hammers, and also I'll refit the springs. I'll make up a replacement spring for the missing one, and then that should be getting fairly close to having the machine completely reassembled. That's the top plate refitted. Just check the hammers can move. If any of these now bind up, it's because they've dropped out of their guides, so we need to tear the side off the machine to refit them. So they should be nice sliding fit, which they are. Generally speaking, if the end one's okay, then the rest will be, but just check them all and they'll look fine. Check that the roller will rotate. I did of course straighten the shaft as well, so okay, it's looking good so far. No tight spots. So I just now need to refit the paper guides, and we can then try running it. Just quickly check the tape or ribbon direction control. These were really stiff before, so as you can see they're now nice and free, so that's another thing that's working. So I'll get the paper guides refitted, a little bit of paper, put a bit of ribbon in there, and we'll see what happens. I finished reassembling the machine. I've made up a replacement spring for the one that was missing. I've, as you can see, got a piece of paper in here, a piece of ribbon, and we'll try and print and see if it's improved things at all. and it has. I can now read the print quite clearly. Try it again. Okay, that is much better. I don't know how well this is coming across on the camera. The camera doesn't seem to pick up this printed text for some reason, but I'll try and zoom you in and hopefully you'll be able to see it fairly clearly. I don't know how well that's coming across. This is a fairly old piece of ribbon now as well, so what I'm looking for is even printing for from top to bottom of the character. Before it was only printing a portion of the character, so we'll try entering a number 654321 and see what comes out. 654321 So okay, so it's actually printing very clearly and it's very even top to bottom, so it looks like our replacement roller is doing what it's supposed to. What I can do now is make up a proper replacement ribbon for this with some decent ink left in it, and we should then get some very good clear printing. Also notice that unlike before when I had to print twice because the ratchet wasn't really working, it's now driving up so we can see the text each time it prints it. We don't have to print again or manually wind it up. So we'll try one more number, 1 2 3 4 5 1, and we'll try printing that. 1 2 3 4 5.10.0. So that's good as well. One last try. We'll see if the end column works. So it should now have a quarter symbol on the right hand side, which it does. So okay, our repair so far is working well. The roller is doing its job, and it looks like our poor printing was because the original roller had petrified, basically turned to a piece of stone, and that wasn't allowing the hammers to do their job properly. They couldn't kind of push their entire character onto the paper because what was behind was too hard and curved. So that's looking good, and what I can do in the next video is start putting this through its paces. I do now have some proper paper reels. I just need to machine up a reel holder shaft so I can clip those in, and we can then start testing the rest of the functions for the calculator. I don't know if this can even add yet. I haven't tried that. All I've done so far is try printing the initial number. So we'll get on, and in the next video we'll see if this can actually add any numbers together.